November 20th, 1944. The waters of Leyte Gulf, Philippine Islands. Dawn arrived as a pale smudge on the eastern horizon, illuminating a sight that would have been incomprehensible to military planners just 3 years earlier. Stretched across the grey expanse of ocean, more than 400 amphibious vessels moved toward the beaches of Leyte Island in formation so vast, it seemed to defy the very concept of naval logistics. But it was not the quantity of ships that would have arrested the attention of any Japanese observer concealed in the island's interior. It was what happened next. At precisely 1000 hours, the first of 29 landing ships, tank each 328 feet in length, each carrying up to 20 Sherman tanks, or their equivalent in armoured vehicles, drove their blunt bows directly onto the sandy beaches. Without cranes, without piers, without the laborious process of offloading that had defined amphibious warfare since men first thought to carry war across water, these vessels simply opened massive bow doors, dropped steel ramps, and disgorged their entire cargo of armoured fighting vehicles directly onto hostile shores. Within minutes, American tanks were rolling inland under their own power, engines warm, crews ready, arriving at the front line not as equipment to be assembled but as combat-ready weapons systems. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. For Japanese defenders watching this spectacle through field glasses and periscope sights, the implications were immediate and devastating. The Americans had solved a problem that military theorists had considered fundamental to amphibious warfare: how to deliver heavy armor to a contested beach without vulnerable periods of assembly, unloading, and organization. The LST represented something more profound than innovative engineering. It embodied an entirely different conception of how industrial capacity could be translated directly into battlefield advantage, bypassing traditional limitations that had constrained military operations since the beginning of mechanized warfare. This moment at Leyte Gulf marked a culmination, not a beginning. The story of how the LST came to dominate Pacific amphibious operations requires understanding the world that existed before November 1944, a world in which both Japanese and American military planners operated under assumptions about amphibious warfare that the LST would render obsolete. Those assumptions had been forged through decades of military experience and represented the conventional wisdom of an entire generation of naval officers. In the spring of 1942, as Japanese forces completed their conquest of the Philippines, the Malay Peninsula, and the Dutch East Indies, the Imperial Japanese military could claim ownership of the most sophisticated amphibious warfare doctrine in the world. This was not mere propaganda or nationalist self-congratulation. It was demonstrable fact, acknowledged by Allied military observers who studied the early Japanese campaigns with a mixture of professional respect and urgent concern. The Japanese had begun developing specialized amphibious capabilities in the 1920s, recognizing earlier than most powers that modern warfare in the Pacific would require the ability to project force across water onto hostile shores. Unlike the Americans or British, who approached amphibious warfare as a specialized subset of naval operations, the Japanese treated it as a fundamental military capability requiring dedicated equipment, specialized training, and close cooperation between Army and Navy forces that had historically maintained strict operational separation. By 1932, the Imperial Japanese Army had deployed the Daihatsu-class landing craft, a 14-meter steel-hulled vessel with a hinged bow ramp that could be lowered to discharge cargo directly onto beaches. The design was sophisticated for its time, capable of carrying 70 troops or 1 light tank or 10 tons of general cargo. More importantly, the Daihatsu represented systematic thinking about the logistics of amphibious warfare. Japanese planners understood that the critical moment in any amphibious operation was not the approach voyage, but the transition from sea to land, that vulnerable period when troops and equipment existed in neither element, exposed to enemy fire while unable to effectively return it. The Americans had studied these Japanese landing craft carefully. In 1937, Marine Corps officer Victor Krulak observed Japanese amphibious operations during the Second Sino-Japanese War and photographed the Daihatsu-class craft. These photographs eventually reached Andrew Higgins, the boat builder who would design the landing craft, vehicle, personnel, the famous Higgins boat that would carry American troops ashore at Guadalcanal, Tarawa, and Normandy. The Americans were learning from the Japanese, adapting enemy innovations to American industrial capacity. But the Japanese advantage in amphibious warfare extended beyond equipment. Between August 1937 and March 1941, Japanese forces conducted 16 amphibious landings on hostile shores, refining their doctrine through combat experience. They had developed specialized naval landing forces, the Rikusentai, trained specifically for ship-to-shore assault. They had created the world's first landing craft carrier ships, the Shinsu Maru and Akitsu Maru, innovative vessels with floodable well decks that could carry landing craft, troops, and even armored gunboats. By the time Japan attacked Pearl Harbor on December 7, 1941, its amphibious forces represented the culmination of 2 decades of focused development. The attacks that followed demonstrated this superiority with brutal clarity. The Philippines fell in 5 months. Malaya and Singapore, supposedly impregnable, fell in 10 weeks. The Dutch East Indies were conquered in 3 months. In each campaign, Japanese forces executed complex amphibious operations with a speed and coordination that Allied commanders found difficult to counter. American military observers documenting these defeats noted specific Japanese capabilities with concern. Japanese landing forces arrived ready to fight, not ready to organize. Their landing craft were designed to minimize the vulnerable period between ship and shore. Their doctrine emphasized rapid movement from water to inland objectives, preventing defenders from organizing effective resistance at the beach. Most troubling, the Japanese had clearly solved problems of inter-service cooperation that bedeviled American and British forces, achieving seamless coordination between naval gunfire, air support, and ground forces during the critical moments of amphibious assault. But underneath this apparent Japanese mastery of amphibious warfare lay limitations that were not immediately visible to observers watching the triumphant campaigns of early 1942. These limitations were inherent to the Japanese approach, structural rather than tactical, and they would become progressively more significant as the war continued. The Daihatsu landing craft, sophisticated though it was, could carry only 1 light tank or 70 men. Multiple trips were required to land any substantial force. The process of building up combat power ashore remained sequential rather than simultaneous. First wave infantry, then support weapons, then light armor, then supplies, each phase dependent on landing craft, making the journey from ship to shore and back again. The mathematics of this process imposed unavoidable constraints. With a finite number of landing craft, the rate at which forces could be built up ashore was fixed. Accelerating the process required either more landing craft, difficult to construct in the numbers required, or accepting increased risk by overcrowding existing craft. More fundamentally, the Japanese approach to amphibious warfare, for all its sophistication, remained constrained by the same logistics that had limited amphibious operations throughout history. Tanks and heavy vehicles still had to be offloaded from transports onto landing craft using shipboard cranes and tackle, a slow process that created vulnerability. If the transport was damaged or sunk before completing this process, the armored vehicles were lost. If the landing craft was damaged or sunk during the approach to shore, the vehicle went to the bottom. Each transfer point represented a moment of maximum vulnerability and minimum capability. Japanese planners understood these limitations. They mitigated them through superior training, careful planning, and aggressive tactics designed to seize objectives before defenders could bring full weight of defensive fire to bear. Their early successes suggested this approach was adequate. The speed of Japanese victories in the first months of the war masked the underlying constrained nature of their amphibious logistics. But American planners, studying these Japanese operations from bases in Hawaii and Australia, were drawing different conclusions. They recognized that Japanese amphibious superiority was tactical and operational, not industrial. The Japanese had better doctrine and more experience, but their approach remained fundamentally conventional in its relationship between industrial capacity and battlefield capability. Equipment still had to be manufactured, shipped across oceans, offloaded onto landing craft, transported to shore, and assembled for combat in sequential steps that could be disrupted at multiple points. The Americans, facing the necessity of conducting amphibious operations across the vast distances of the Pacific against an enemy that had demonstrated clear superiority in amphibious warfare, began to consider a different approach. Rather than simply copying Japanese methods at larger scale, American planners and engineers began thinking about how to eliminate steps from the process entirely, how to collapse the time between industrial production and battlefield deployment, how to deliver combat power not as components to be assembled, but as integrated systems ready for immediate action. This thinking would lead to innovations that seemed, on first consideration, almost absurd in their ambition. Ships that could cross oceans, then deliberately beach themselves on hostile shores. Vessels that could carry not landing craft but tanks themselves, delivering them directly from factory floor to front line in a single integrated operation. The concept seemed to violate fundamental principles of ship design and naval architecture. Ships were meant to stay afloat, not intentionally ground themselves. Cargo vessels were designed to load and unload at piers, not on beaches. But by late 1941, as the United States absorbed the reality of entering a global war simultaneously against Germany and Japan, conventional thinking no longer seemed adequate to the challenge. The question was not whether such vessels were possible according to existing naval architecture principles. The question was whether they were necessary, and, if necessary, could American engineering and industrial capacity make them real? The concept that would become the landing ship tank did not originate in the United States. It came from Britain, from Winston Churchill specifically, who had spent decades thinking about amphibious warfare and who understood that the evacuation from Dunkirk in May 1940 had exposed a critical gap in Allied capabilities. The British Army had escaped France, but had left behind essentially all its heavy equipment. Returning to the continent would require the ability to land armor directly onto hostile beaches without depending on port facilities that the enemy would certainly destroy before evacuation. In November 1941, a British delegation visited the United States Navy's Bureau of Ships with a request: design a vessel capable of carrying tanks across the Atlantic Ocean and landing them directly on beaches. The requirement seemed almost contradictory. Ocean-going vessels needed deep drafts for stability in heavy seas. Landing craft needed shallow drafts to approach close to shore. How could one vessel possess both characteristics? John Niedermeyer, technical director of preliminary ship design at the Bureau of Ships, solved the problem with elegant simplicity. The LST would be designed with large ballast tanks similar to those used in submarines. When filled with seawater, these tanks would give the ship sufficient draft for ocean passage. When pumped out as the vessel approached a landing beach, the draft would be reduced, allowing the ship to drive its bow directly onto shore. The bow itself would be hinged, opening to allow a ramp to drop onto the beach. Vehicles could then drive directly from the ship's tank deck onto land under their own power. The design was approved by the Royal Navy within days. By January 1942, detailed plans were complete. The LST would be 328 feet long, 50 feet wide at the beam, capable of carrying up to 20 Sherman tanks or their equivalent in other vehicles and cargo. Maximum speed would be limited around 11 knots fully loaded, but the vessel would be capable of crossing the Atlantic or Pacific and then conducting landing operations on virtually any gradually sloped beach. What Niedermeyer and his team had created was not simply a new type of ship. They had designed a vessel that functioned as a bridge between industrial production and battlefield deployment, eliminating multiple steps from the conventional process of amphibious warfare. Instead of tanks being loaded onto transports using cranes, then transferred to landing craft, then ferried to shore, then assembled into fighting units, the LST allowed tanks to be driven aboard at the factory or staging area, and remain aboard until they drove directly onto hostile beaches, engines running, crews ready, weapon systems operational. The first LST was laid down in June 1942, just 7 months after the initial design concept. By the end of 1942, American shipyards were producing LSTs at a rate that would have seemed impossible a year earlier. The vessels were built not at traditional naval shipyards on the coasts, but at facilities throughout the American industrial heartland. Shipyards in Pittsburgh, Pennsylvania, and Evansville, Indiana, hundreds of miles from any ocean-constructed LSTs that were then sailed down the Mississippi River to the Gulf of Mexico for fitting out and deployment. And so on November 20th, 1944, when those 29 LSTs drove their bows onto the beaches at Leyte Gulf and disgorged their cargoes of tanks directly onto hostile shores, they were demonstrating capabilities that represented a fundamental transformation in how industrial nations could project military power. The Japanese defenders watching this operation unfold were witnessing not just a tactical innovation, but a systemic advantage that their own amphibious warfare doctrine, sophisticated as it was, could not match. For the Americans had done something that the Japanese approach to amphibious warfare, for all its tactical excellence, could not replicate. They had collapsed time itself, eliminating the sequential process of building combat power ashore and replacing it with direct delivery of integrated fighting capability. Where Japanese doctrine required hours or days to accumulate sufficient force ashore for sustained offensive operations, American LSTs could deliver that force in the time it took to drive vehicles off a ramp. The implications extended far beyond the beaches of Leyte. What Japanese observers were seeing was not simply better equipment or superior numbers, though the Americans certainly possessed both. They were seeing a different relationship between industrial capacity and battlefield capability, one that rendered obsolete many of the assumptions that had guided Japanese military planning since the 1920s. This was the foundation of the crisis that Japanese military planners would face as they attempted to understand and respond to American amphibious operations. The LST was not just a ship, it was visible evidence that American industrial organization operated on fundamentally different principles than Japanese production, principles that allowed the Americans to deliver military capability at scales and speeds that Japanese doctrine had not anticipated and Japanese industry could not match. The LST designated LST-766 arrived off the eastern coast of Leyte Island at 09:45 hours on the morning of November 20th, 1944. She was one of 29 LSTs in the assault wave, part of the largest amphibious invasion force yet assembled in the Pacific War. Her specifications were precise, documented in the vessel's operating manual to tolerances that left no room for interpretation. Length, 328 feet. Beam, 50 feet. Draft when ballasted for ocean transit, 14 feet 1 inch aft, 8 feet 3 inches forward. Draft when deballasted for landing operations, 3 feet 11 inches forward, 9 feet 10 inches aft. This shallow draft was the vessel's defining characteristic, allowing it to approach within yards of shore on beaches with gradual slopes. This process repeated at 28 other points along the invasion beaches that morning. By noon on November 20th, more than 350 Sherman tanks had been delivered directly onto Leyte Island, along with hundreds of trucks, artillery pieces, and supply vehicles. The tanks that rolled off the LSTs at 1000 hours were engaging Japanese defensive positions by 11:30 hours, less than 90 minutes after landing. Japanese defenders observing this operation from concealed positions in the interior recognized immediately that something fundamental had changed in American amphibious capabilities. Colonel Jiro Wakamatsu, intelligence officer of the Japanese 16th Division defending the Tacloban area, documented his observations in a report later captured by American forces. The report, dated November 21st, 1944, noted with what can only be described as professional dismay the speed at which American armored forces had moved from ship to shore to combat operations. The enemy possesses vessels capable of delivering armored vehicles directly to the beach without requiring transfer to smaller craft, Wakamatsu wrote, the translation preserving the clinical precision of his assessment. These vessels approach to within meters of the shore, open their forward sections, and discharge their entire cargo of tanks in less than 1 hour. The tanks arrive operational, with crews already aboard, and move immediately to engage our positions. This eliminates the vulnerable period we observed in previous American landings where tanks required assembly or organization after reaching shore. Wakamatsu's report continued with calculations that revealed the strategic implications he understood all too well. At current rates, The enemy can land approximately 300 armored vehicles per day at a single beach. Multiple beaches allow proportional multiplication of this capability. Within 3 days of initial landing, enemy armored strength ashore exceeds the total armored capability of our entire 35th Army, defending all Philippine Islands. The numbers in Wakamatsu's report were accurate. The 35th Army, responsible for defending the central and southern Philippines, possessed approximately 200 Type 95 light tanks and Type 97 medium tanks scattered across multiple islands. Each weighed between 7 and 15 tons. Main armament ranged from 37mm to 47mm guns with limited ammunition capacity. The Type 97 medium tank, the most capable vehicle in Japanese inventory, weighed 15 tons and mounted a 47mm gun with 120 rounds specifications that made it roughly comparable to American tanks of 1938. Against this force, American LSTs were delivering Shermans that weighed more than twice as much, carried guns with substantially greater range and penetrating power, and arrived at rates that Japanese logistics simply could not match. But the disparity in armored capabilities, significant though it was, represented only part of the challenge Japanese planners confronted. The LST itself embodied principles of logistics that Japanese military production had not implemented at scale. Each LST could make multiple trips, shuttling between offshore transports and the beach, delivering new loads every few hours. The vessels required minimal specialized port facilities. They could land on any beach with appropriate gradient. Damage to one LST did not critically degrade the overall landing operation because dozens of other vessels maintained the flow of supplies and equipment. Most significantly, the LST eliminated the sequential steps that had characterized all previous amphibious operations. Tanks no longer needed to be craned from transport ships onto landing craft, then ferried to shore, then assembled into combat formations. The entire process collapsed into a single integrated operation. Tanks rolled onto LSTs at departure ports, remained aboard during ocean transit, and rolled off directly into combat zones. This represented a fundamental transformation in how industrial capacity translated into battlefield capability. American factories in Detroit were producing Sherman tanks at rates approaching 2,000 per month by late 1944. Those tanks could now move from factory floor to combat zone in an unbroken chain of transport. Rail to port, LST to beachhead, direct engagement with enemy forces. The time from manufacture to battlefield deployment had been reduced from months to weeks. Japanese observers watching this process understood they were witnessing something beyond superior numbers or better equipment. They were seeing evidence of industrial organization operating at scales that Japanese production methods could not approach. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The full impact of LST operations became clear to Japanese military planners not during the initial landings at Leyte, but during the subsequent American campaign to capture Ormoc Bay on the western coast of Leyte Island. This operation, conducted on December 7, 1944, would demonstrate capabilities that fundamentally challenged Japanese assumptions about defensive planning. Ormoc Bay represented the primary Japanese supply route to their forces defending Leyte. Japanese planners had concentrated their defensive preparations on the eastern coast, where the initial American landings had occurred. The assumption, based on conventional amphibious warfare doctrine, was that American forces would need weeks to build up sufficient supplies and equipment after the initial landing before they could mount major offensive operations against other parts of the island. This assumption proved catastrophic. On the morning of December 7th, less than 7 weeks after the initial Leyte landings, an American amphibious force appeared off Ormoc Bay on the opposite coast of the island. The force included 12 LSTs carrying elements of the 77th Infantry Division, along with supporting artillery and armored vehicles. Japanese coastal observers watched in disbelief as these vessels approached directly to shore and began offloading. Major General Yoshiharu Tomochika, Chief of Staff of the Japanese 35th Army, later testified during post-war interrogations about the psychological impact of this operation. His testimony, preserved in United States Strategic Bombing Survey records, provides remarkable insight into how Japanese military leaders understood the implications of LST capabilities. We had planned our defense assuming the Americans would require substantial time to accumulate supplies at their initial landing points before conducting additional operations, Tomochika stated during interrogation in October 1945. The appearance of major forces at Ormoc, supplied directly from their ships, eliminated our defensive strategy. They did not need to build up supplies gradually. They simply brought everything they needed directly to any beach they chose. Tomochika's testimony continued, with calculations that revealed how completely LST capabilities had undermined Japanese defensive planning. Our intelligence had observed similar vessels at previous American landings, but we had not understood their full significance. We assumed they were specialized ships for initial assault only. At Ormoc, we understood these vessels were not merely assault craft, but mobile supply bases that could sustain extended operations. The Ormoc landing involved approximately 25,000 troops, and their supporting equipment delivered directly onto hostile beaches in less than 48 hours. This included medium tanks, artillery pieces, trucks, ammunition, medical supplies, and sufficient food and water to sustain operations for 2 weeks. All of this arrived not through gradual build-up from distant supply bases, but through direct delivery from offshore vessels to beachheads. Japanese forces defending Ormoc had prepared defensive positions based on the assumption that American forces would need to establish supply lines across the mountainous terrain of Leyte's interior. Those defensive positions became irrelevant when American forces simply sailed around the island and landed directly at their objective, bringing their entire logistics base with them. This production disparity reflected fundamental differences in industrial organization. American shipyards building LSTs in Pittsburgh and Evansville had implemented assembly line production methods, with standardized components manufactured by suppliers throughout the industrial base, then assembled by workers who required relatively limited specialized training. Japanese shipbuilding remained craft-based, with vessels constructed by skilled workers at traditional naval yards that could not rapidly scale production. The No. 1 class ships also revealed the constraints that Japanese strategic situation imposed on design decisions. Unlike American LSTs, which could be designed purely for amphibious assault operations, Japanese landing ships needed to be fast enough to serve multiple roles, including transport, mini-laying, and escort duties. This requirement for speed meant the vessels needed more powerful engines, which increased complexity and reduced cargo capacity, compared to the deliberately slow but capacious LST design. Japanese engineers who examined American LSTs captured late in the war documented their findings in technical reports that preserved their professional assessments. One such report, prepared by the Kure Naval Arsenal in 1945, based on examination of a damaged LST that had grounded near Okinawa, noted with clinical precision the characteristics that made these vessels effective. The construction methods emphasize mass production over individual craftsmanship, the report observed. Hull sections are welded, rather than riveted, using standardized plate dimensions. Main engine components are interchangeable across multiple vessel classes. Cargo handling equipment uses standardized fittings and connections. These design choices sacrifice some performance characteristics, but permit rapid production by workers without extensive shipbuilding experience. The report continued with observations that revealed the author's understanding of what American LST production represented. The number of these vessels observed suggests production rates far exceeding conventional shipbuilding capacity. This implies manufacturing organization treating ships as mass-produced vehicles rather than individually crafted vessels. Such organization requires industrial infrastructure and standardization beyond current Japanese capabilities. That final sentence captured the essential reality Japanese planners confronted. The LST was not simply a clever ship design that Japanese industry could copy if given sufficient time and resources. It represented an entire approach to industrial organization that treated military equipment as products of systematic manufacturing rather than specialized craftsmanship. American factories could train workers in weeks to build LSTs because the ships were designed from the beginning to be producible by semi-skilled labor using standardized components and systematic assembly procedures. Japanese shipyards required years to train craftsmen because their vessels were designed to be built by skilled workers who could adapt and fit components individually. Neither approach was inherently superior in all circumstances. Japanese construction methods produced warships of excellent quality and sophisticated capability, but when the requirement was to build hundreds of large cargo vessels as rapidly as possible, American mass production methods possessed overwhelming advantages. By early 1945, Japanese military planners understood that the war could not be won through superior tactics or fighting spirit when facing opponents who possessed the industrial capacity to deliver combat power at scales that overwhelmed defensive preparations. The LST had become the visible symbol of that industrial disparity, the physical manifestation of American ability to translate manufacturing capacity directly into battlefield capability. The final recognition came not from military planners but from Japanese soldiers who encountered the results of LST operations at ground level. Their testimonies, recorded in post-war interrogations, provided ground truth about what industrial superiority meant in practical terms. Private Takashi Nakamura, captured on Leyte in January 1945, described his unit's experience facing American forces that had been landed and supplied by LSTs. His interrogation, conducted by Allied intelligence officers and preserved in war crimes trial records, included details that statistical reports could not capture. "We had been told that American supply lines were extended and vulnerable," Nakamura testified through a translator. "We were told to hold positions and the enemy would exhaust his supplies and be forced to withdraw, but the supplies never stopped arriving. Every day we observed their ships bringing more tanks, more trucks, more ammunition. They would drive these vehicles directly onto the beaches and inland to their positions. We had no supplies beyond what we could carry. They had everything they needed delivered directly to the battlefield." This testimony appeared in multiple interrogations across different units and different islands. Japanese soldiers consistently reported surprise at the abundance of American supplies and the rapidity with which equipment was delivered to forward positions. They had been trained to expect that defending forces would possess advantages in supply and logistics. The LST had inverted that assumption. Lieutenant Colonel Masao Yoshida, operations officer for the Japanese 16th Division on Leyte, provided even more specific observations during his interrogation in February 1945. His testimony included technical details that demonstrated professional military understanding of what he had witnessed. "The American vessels we observed could deliver approximately 20 tanks directly to shore in under 1 hour," Yoshida stated. "They would then retract from the beach and return with additional loads. We calculated that a single beach could receive over 100 tanks per day from these vessels. Our division possessed 18 tanks total. In 3 days of American landing operations, they brought ashore more armor than existed in our entire army defending the Philippines." Yoshida's calculations were accurate. The initial American landings at Leyte had delivered over 350 tanks in the first day. By the end of the first week, American armored strength on Leyte exceeded 700 vehicles. Japanese armor strength across all the Philippine Islands totaled approximately 200 tanks. But the disparity went beyond mere numbers. Yoshida's testimony continued with observations about how this numerical superiority translated into operational advantages. "Our tanks could not be replaced if destroyed. American tanks that were damaged were often repaired and returned to service within days. They appeared to have unlimited spare parts, delivered by the same ships that brought the original vehicles. We observed American mechanics replacing entire engines in the field, using equipment that arrived on their landing ships." This observation highlighted another advantage that LST operations provided. The vessels did not just deliver combat equipment, but brought the entire logistics base required to maintain that equipment. LSTs regularly carried machine shop equipment, spare parts inventories, and maintenance crews along with the combat vehicles themselves. American tank battalions could conduct major repairs at forward positions because they possessed the tools and parts needed, all delivered by the same LSTs that brought the tanks. The psychological impact of facing opponents with such overwhelming material advantage appeared repeatedly in Japanese soldier testimonies. Sergeant Kenji Yamamoto, captured on Luzon in March 1945, described the effect on his unit's morale of constantly observing American ships arriving with fresh supplies and equipment. "We were hungry," Yamamoto stated simply during interrogation. "We had insufficient ammunition. Many soldiers were sick or wounded with no medical supplies available. Every day we watched American ships arrive at the beaches, bringing everything they needed. Food, ammunition, medicine, vehicles, everything. They would simply drive up to the beach, open the front of their ships, and unload tanks and trucks that drove away immediately to their positions. We knew we could not win against opponents who possessed such abundance." This testimony reflected a broader collapse in Japanese defensive morale that American intelligence officers documented throughout the final year of the Pacific War. Japanese soldiers consistently reported that their training and indoctrination had prepared them to face enemies who were soft, undisciplined, and dependent on material comfort. The reality they encountered was opponents who possessed not just better equipment, but such overwhelming quantities of equipment that Japanese defensive preparations became irrelevant. The testimonies also revealed Japanese soldiers' respect for what they recognized as superior industrial organization rather than individual American superiority. Multiple interrogation reports included statements acknowledging that American soldiers were not necessarily better trained or more courageous than Japanese troops. But American forces possessed material advantages so overwhelming that individual qualities of soldiers became secondary factors. Master Sergeant Hiroshi Tanaka, a veteran who had fought against American forces on Guadalcanal, New Guinea, and Leyte, provided perhaps the most succinct summary during his interrogation in April 1945. Asked to compare American capabilities across different campaigns, Tanaka responded, "At Guadalcanal, they brought supplies slowly and their positions were vulnerable to our counterattacks. At New Guinea, their supply lines improved but remained constrained. At Leyte, they simply brought everything they needed directly to any beach they chose. We could not attack their supply lines because their supply lines were ships that arrived, unloaded, and departed. We could not cut them off because they were never extended. They possessed mobility that made our defensive positions obsolete." Tanaka's observation captured the strategic transformation that LST operations had produced. Traditional military doctrine held that attacking forces faced inherent disadvantages in supply and logistics. Defenders could prepare positions, accumulate supplies, and force attackers to extend vulnerable supply lines. The LST eliminated these traditional advantages by allowing attacking forces to bring their entire logistics base directly to any point they chose to assault. By May 1945, as American forces prepared for the invasion of the Japanese home islands, Japanese military planners understood that their defensive strategy faced opponents who could land wherever they chose, in whatever strength they chose, with whatever supplies they needed, all delivered directly to beaches by vessels their forces could neither stop at sea nor attack effectively once landed. This recognition informed the desperate defensive preparations for the anticipated invasion of Kyushu. Japanese planners abandoned attempts to defend the beaches and instead concentrated forces inland, accepting that American landings would succeed and could not be prevented through coastal defense. The assumption was that Japanese forces might inflict casualties through sustained resistance, but direct opposition to American amphibious capabilities had proven futile. That invasion never came, but the recognition of American industrial superiority, demonstrated daily through the operations of vessels like the LST, had already convinced Japanese military leaders that the war could not be won through military means alone. The hope, increasingly desperate as 1945 progressed, was that inflicting sufficient casualties might force negotiated peace rather than unconditional surrender. The LST had become more than a ship. It was physical proof that American industrial capacity could produce military equipment at scales and speeds that Japanese planning had not anticipated, and Japanese production could not match. Every time an LST drove its bow onto a hostile beach and disgorged 20 tanks directly into combat, it demonstrated a level of industrial organization that rendered conventional defensive planning obsolete. The landing ship tank returned to its Pacific routine, but what it carried back was more than cargo. When the first LSTs beached at Leyte Gulf in October 1944, Japanese shore observers radioed reports that read like fever dreams. 27 Sherman tanks rolling directly from ship hulls onto volcanic sand. No lighters, no cranes, no pause. The defending garrison commander at Tacloban filed a situation report that used the phrase unprecedented landing capacity 3 times in 4 paragraphs. Intelligence officers in Manila initially dismissed the reports as exaggeration born of combat stress. They were not exaggerations. Within 6 weeks, captured Japanese planning documents revealed a fundamental recalibration. Imperial General Headquarters issued revised coastal defense protocols in November 1944, specifically addressing what they termed direct armor deployment vessels. Beach obstacle, construction priorities shifted. Where previous doctrine had emphasized shallow water barriers designed to strand conventional landing craft, new directives called for deeper placement of tetrahedrons and log ramps positioned to damage LST bow doors in 4 to 6 feet of water. Concrete pillboxes received modified firing apertures angled to engage vehicles at the waterline rather than suppressing infantry on the beach crest. The LST had forced doctrinal change through sheer material fact. The statistical record tells its own story. At Leyte Gulf in January 1945, American forces landed 68,000 troops and supporting armor in the first 24 hours. The LST fleet delivered 11 tank battalions directly to shore without a single vehicle lost to landing failure. Japanese after-action reports from surviving defenders noted that counterattack windows collapsed because armor arrived in formation strength before infantry consolidation was complete. Traditional amphibious theory held that tanks would trickle ashore over days, allowing defenders to engage them piecemeal. The LST compressed that timeline to hours, but the vessel's psychological impact outweighed even its tactical advantage. A Marine Corps intelligence summary from February 1945, compiled from interrogation transcripts of prisoners taken at Iwo Jima, included a recurring theme. Japanese troops described a specific moment of realization when LST bow doors dropped and armor appeared. Not surprise. Realization. The understanding that American industrial capacity had solved a problem so fundamental that most military theorists considered it unsolvable. You do not casually produce a ship that beaches itself, unloads 20 vehicles, and retracts under its own power. You produce such vessels when your manufacturing base operates at a scale your opponent cannot comprehend. One CB battalion engineer, interviewed during the Okinawa campaign in April 1945, put it more directly. He had watched LST operations from Guadalcanal through the Philippines. The Japs fought like hell at every beach, he said, but once those ships started dropping ramps with Shermans already rolling, you could see it in their fire patterns. They weren't trying to win anymore, they were trying to make it cost us. That shift from offensive defense to attrition warfare marked a strategic surrender, even when tactical resistance continued. The LST did not win the Pacific War. No single weapons system does, but it eliminated a constraint that had governed amphibious warfare since men first fought from ships. It took the logistical bottleneck that occurred at the water's edge and widened it into an avenue. When Japanese planners studied American capabilities in late 1944, trying to understand how to defend their remaining territories, the LST appeared in their threat assessments not as a landing craft, but as a statement of industrial inevitability. Numbers became doctrine in ways their original designers never anticipated. The United States Navy commissioned 1,051 LSTs between 1942 and 1945, not prototype vessels, not limited production runs. 1,051 functional, operational ships, each capable of beaching itself and delivering a mechanized platoon directly onto hostile shore. The scale of production transformed tactical innovation into strategic certainty. When American planners designed island campaigns in the Central Pacific, LST availability was not a constraint to work around. It was a baseline assumption. Consider Okinawa, April through June 1945. The landing plan called for simultaneous assault beaches across 8 miles of coastline, with armoured support arriving in the first wave at 5 separate points. no logistical pause, no equipment assembly on the beach, tanks rolling ashore while naval gunfire still suppressed inland positions. Japanese defensive plans, captured after the battle, had anticipated armor arriving on the second or third day, allowing time to reposition anti-tank guns and prepare ambush positions along the coastal roads. Instead, American Shermans were engaging inland targets within 90 minutes of the first infantry wave. The LST had compressed the amphibious assault timeline so thoroughly that enemy doctrine could not adapt. British observers noted the operational implications with professional precision. A Royal Navy after-action analysis from the Sicily landings in 1943, where British forces used American-supplied LSTs, concluded that the vessel renders obsolete previous assumptions regarding the tempo of amphibious operations. The report was not celebrating American ingenuity, it was documenting a capability gap. British shipyards could not match American LST production rates even when building from American plans. The industrial capacity required to manufacture these vessels at scale was itself a strategic weapon. Soviet forces received 30 LSTs through Lend-Lease, using them for Black Sea operations in 1944. Their tactical employment reports, translated by American liaison officers, described the vessels in almost reverential terms. One Soviet naval infantry commander wrote that the LST allowed his unit to execute a landing operation that previous doctrine would have classified as impossible without air superiority and preliminary naval bombardment. They beached their vessels, delivered armor, and withdrew before German coastal artillery could adjust fire. The operation succeeded not because of superior tactics, but because the LST made certain tactics feasible. The vessel's influence extended beyond the war itself. When military theorists began analyzing amphibious warfare in the post-war period, the LST became the reference standard. Cold War planning for potential European campaigns assumed LST-scale landing capacity. The Soviet Navy developed their own beaching vessels, the Ropucha and Alligator classes, explicitly designed to match LST capabilities. The vessel that began as a solution to a specific Pacific problem became the template for a generation of amphibious warfare. Post-war, hundreds of LSTs continued operational service. The Korean War saw them delivering supplies directly to contested beaches. Vietnam operations used LSTs as mobile bases. Some served into the 1970s. They were not graceful ships. They were not particularly fast or well-armed. But they worked, and they kept working, because the fundamental problem they solved remained relevant. The measure of military innovation is not elegance, but consequence. The LST possessed neither speed, nor armor, nor sophisticated weaponry. It was a functional vessel designed to solve one problem: how to deliver heavy vehicles from ship to shore without intermediate handling. That solution changed amphibious warfare more profoundly than any doctrinal revision could have achieved. When Japanese coastal defenders watched those bow doors open and tanks roll directly onto Pacific beaches, they witnessed the material expression of American industrial philosophy. Build the tool that eliminates the problem. After 1945, LST hulls found second lives across unexpected roles. Commercial shipping firms converted them into vehicle ferries. Aid organizations used them to deliver relief supplies to disaster zones. Several became floating fish processing facilities. The vessels outlived their original purpose because their fundamental design, cargo accessibility combined with beaching capability, remained valuable in peacetime logistics. That adaptability reflected the same practical engineering that made them effective in war. The human cost of amphibious warfare did not disappear with LST deployment. Men still died on Pacific beaches. But the vessel changed the equation at the water's edge, where attackers were most vulnerable. It reduced the time troops spent exposed during landing, compressed the period before armor support arrived, and increased the material weight of first-wave assaults. These were incremental advantages measured in minutes and tonnage, but amphibious assault operates on such thin margins that incremental advantages determine outcomes. Veterans of Pacific campaigns rarely spoke about LSTs, with the affection reserved for fighter planes or battleships. The vessels were utilitarian, uncomfortable, and unspectacular, But in post-war interviews and memoirs, a pattern emerges. When describing successful landings, when explaining how they survived assaults that doctrine suggested should have failed, they mentioned the LSTs, not dramatically, almost as afterthought. The tanks came right off the ships. That casual observation represented a transformation in warfare that Japanese defenders recognized immediately, and historians spent decades properly contextualizing. The LST did not define the Pacific War. That distinction belongs to the men who fought it, the strategies that guided them, and the sacrifices that bought each contested island. But the vessel made certain operations possible that previous technology could not support. It was a tool that matched the requirement of its moment, a pragmatic answer to a tactical problem, built in numbers that transformed capability into inevitability. When the last LST retired from active service, it left naval warfare fundamentally different than it found it. Military history turns on such practical revolutions more often than on dramatic breakthroughs. The LST represents that tradition, an ungainly ship that solved an impossible problem by refusing to accept that the problem was impossible. 20 tanks rolling directly from hull to beach, eliminating the vulnerable transition that had constrained amphibious warfare since ancient times. Simple in concept, revolutionary in effect, decisive in application. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.